Welcome to Chapter 5, Lesson 3. Our essential question remains the same. How can I use place value and properties to add and subtract decimals? We have not learned about the properties yet, but that is coming soon. We are on page 315. Problem solving investigation. Estimate or exact answer. This is an important lesson because there are genuinely times in life where we don't need the exact answer. We just need an estimate. So this will be some good practice in trying to decide which one do we need based on the situation at hand. Mrs. Trainer needs to purchase a classroom response clicker and a new calculator. A clicker costs $31.99 and a calculator costs $11.75. About how much money will it cost to buy both? Just like our other problem-solving lessons, we first need to identify what do we know? That she needs to buy both a clicker and a calculator for $31.99 and $11.75. What do we need to find? About how much it will cost to buy the clicker and the calculator. What is our plan? You can add or estimate because we just need to know about. Kind of depends on which way your brain went, but round the costs of the clicker and the calculator to the nearest whole dollar. So that's going to be our plan to solve because we just need an estimate. To the nearest whole dollar. Dollar means ones place. So we underline our ones and we look to the neighbor. 9 is greater, so we're going to round up to 2, but we can't just ignore the 30 in the tens place. Whatever happens to the left needs to stay. Whatever happens to the right, or whatever digits are on the right, will change to zeros after we've rounded. And then again, whole dollar, ones place, we're going to keep that 1 in the tens place. Look at the 7, that's greater than 5, so we're going to round up to 2 and drop the rest. 32 plus 12 equals 44. So Mrs. Trainer will need to spend about $44. Okay. Estimate another way, right? So we could round to the nearest tens. 30 plus 10 is 40. So that's still close. And 44 is about equal to 40. On to page, oops, you couldn't see part of that. Sorry about that. I'll pause for a second. On to page 316. Madison drove to her grandparents' house. They drove 58 and 6/10 miles in the first hour, 67 and 2/10 miles in the second hour, and 60 and 5/10 miles in the third hour. They followed the same route home to return home. About how far did they go to travel and see family? So far we haven't had one where we do need the exact, but your independent practice will provide some of that. First thing, what do we know? They traveled 58 and 6/10, 67 and 2/10, and 60 and 5/10 miles there, and the same amount back. Okay, what do we need to find? About how far, did they travel in total? Our plan, since it's an about, will be to estimate and then multiply by 2, right, for the return home. So we'll take our 58 and 6/10, 67 and 2/10, 60 and 5/10. And we'll just have to decide, do you want to round to the nearest mile, which would be the ones place, or the nearest 10 miles, which would be the tens place. Let's round to the tens place. Okay, so we have 58. 8 is more than 5, so we'll round our 5 up to 6. We have 67. 7 is more than 5, so we'll round our 6 up to 7. And here we have 60 and 5/10. Our 0 is well under 5, so we'll keep our 6. Add those together, right? 120 plus 70 is 190. And then a quick multiplication problem. 2 times 0 is 0. 2 times 9 is 18. Regroup. 2 times 1 is 2, plus 1 is 3. So they traveled about 380 miles. Okay. If we want to check our work, we could divide by 2 and then subtract. Or since we rounded to the nearest tens, we could round to the nearest ones, where we would have 59, 67, and 61. So again, we still have 128. Which equals 187 times 2. Sorry about that, should have thought that part through. And 374 miles is about equal to 380. All right, have a great day.